This next PowerPoint is on polarization, and this will help you with MOP sub-level number 2, and it will help you with the polarization notes for the MOP. Polarization basically is just taking light waves and making them so that they only will move up and down or left and right or just in one what we call plane of motion. So we know that light travels in waves and the waves are transverse, they're not longitudinal, and we can see that they are transverse waves by a phenomenon called polarization. So let's say that you are this little person here and you're shaking the end of the rope. The waves will travel along that rope. Okay, so notice the vibrations here are only up and down. You could also shake this rope left and right. Light actually shakes it in all 360 directions, and so we say that, that wave, basically, if you can get it in one direction, it's polarized. We can polarize light. Typically, we look at horizontal and vertical just to make it a little bit more simple. Uh, the thing that happens with electrons are electrons vibrate up and down. They also can vibrate left and right or in any of the other 360 degrees. So it's very similar to that rope that you can shake up and down. Whenever somebody looks at polarization, typically what we do is we can look at using something called a polarizing filter or polarizing material. Typically, you'll see these in sunglasses. You also find these in the glasses for 3D movies. So when you go to the Hamilton IMAX and you put on those 3D glasses, they're basically just polarizing filters that are at different angles. And so one eye sees one type of light and one eye sees the other, and that makes the 3D image. It makes it very bright, vibrant. If you look at the picket fences here, you'll notice that the wave, if I shake it up and down, it can go through both of these because notice that they're lined up really well. So light, as it goes through these two polarizing filters, and you'll see these in class, light can go completely through because it is only polarized in one direction, just up and down. And when it hits the second one, it's kind of like going through the second picket fence. It still travels through. If I take the second one and notice that the lines here go up and down, the lines in this one go left and right. So when I make that light that's coming in all 360 degrees hit this filter and it only goes up and down now, if I put a picket fence in the way, kind of like this one or this crate, you'll notice that I don't get that light passing through and it actually is dark. This is going to show you the same thing again, but it also shows you some pictures as to what happens. Here are two polarizing filters. This one polarizes things left and right, and this one polarizes things up and down. So you'll notice that when the molecules in the filter are aligned vertically up and down, the polarization axis is actually horizontal, and then vice versa here. Notice that the molecules in the filter are left to right, so the polarization is actually up and down. So the waves coming out of this will only travel up and down, and the waves here are only left and right. Similar to these picket fences. Let's take the picket fences. Here's your teacher, and you've got two filters, and they are aligned parallel, so they're aligned like these two fences. If you turn this second one and you align it so that it's not parallel but it's perpendicular, you'll notice that it's a lot darker in the center. It actually would be very dark. In fact, I can show you that in this one. We have a lady, light is transmitted through both of these filters because they are aligned. So kind of like the picket fences in the previous slide, they're aligned like this. If I rotate them so that they are no longer aligned like in B, light is actually absorbed by the second filter and you don't see her face at all. Now there's a weird phenomenon that comes on that you can use vectors to try to explain, but if you take a third filter and put it at a 45-degree angle, it actually re-emits that light. It's really kind of a weird effect. Um, the other way to polarize light instead of using a filter is to use water or a flat surface. If you try to skip flat stones across the surface of the pond, they will bounce parallel to the water. Okay? Stones with flat sides at right angles to the surface will actually go into the water. And light behaves the same way. The flat side of the stone is like the plane of vibration of that polarized light. So when light reflects off a non-metallic surface such as glass, water, or roads, it vibrates just in the plane reflecting of the surface. So here you'll see the unpolarized lights pointing in all the directions, hits the water, and then comes off. that's a very difficult light to look at. So if you wear polarizing filters or sunglass lenses, then you will get rid of that glare. And that's the really nice thing about those lenses. And that is the end of polarization.